Let's explore 10 key points that will make it easier for you to understand the TCP/IP network layer function. Hello everyone and welcome. Today I aim to demystify the network layer function by stimulating your curiosity to delve deeper into its key points. Each of these points will act as a key to unlock doors that are essential for a thorough understanding. In the next few minutes, I'll share these keys with you. So, if you're on the lookout for these insights, stick around and keep watching until the end. If you found the information helpful, please subscribe, like, and share this video, and hit the notification bell. Also, please comment on which part of this video was useful for you. If you're as excited as I am, let's get started. What is the TCP/IP network layer? The network layer in the TCP/IP model is responsible for logical addressing, routing, and the efficient transfer of data between devices across different networks. It plays a crucial role in determining the best path of data to travel from the source to the destination. But what I mean by that? Let's look at it briefly. Alright, let's talk about the TCP/IP network layer. The digital maestro of the internet, it wears three hats, and trust me, they're pretty important. First up, we've got logical addressing. Now, think of this as giving every device its own unique digital address, aka an IP address. It's like ensuring each house on our digital street has its distinct number. Cool, right? Now, let's dive into routing. The network layer here transforms into a virtual GPS. Picture a GPS figuring out the best route for your journey well. Our network layer does the same for data. It's the expert navigator, choosing the quickest and most reliable path through the intricate web of networks. Imagine your data as a little parcel on its way. The network layer ensures it takes the express route. Now, let's talk about the orchestration of data transfer. As the maestro, the network layer steps into the role of conductor, coordinating all our instruments or devices to play together in perfect harmony. This coordination is crucial for making sure your data gets delivered reliably and right on time. Think of it like the behind-the-scenes magic that keeps everything flowing smoothly. Addresses are given out, data is directed on the fastest routes, and it orchestrates a flawless performance in the vast realm of the internet. In a nutshell, my friends, the network layer is your digital guide, giving out addresses, directing data on the fastest routes, and orchestrating a flawless performance in the vast realm of the internet. It's like the behind-the-scenes magic that keeps everything flowing smoothly. What is IP addressing and why is it important? Curious about how your gadget navigates the vast internet landscape? Well, that's where IP addressing comes in. Think of it as a digital postal system assigning special digital addresses or IP addresses to each device. It's like giving them a personal passport for the digital world. Imagine the internet as a busy city where each device is a unique house, and the IP address acts as its house number. Now, the network layer plays the role of digital postal service, using these addresses to enter the internet streets and efficiently deliver data through a network of routers. Here's a simple analogy: sending a letter. The postal service just needs the right address, not the content of the letter. Similarly, routers act like internet mail carriers, routing data based on IP addresses without picking at the actual data. This addressing system is the internet backbone. making sure data packets reach their destination accurately, no matter where the device is. In a nutshell, IP addressing is the Internet's language, making device communication smooth and ensuring a seamless flow of information across the vast digital landscape. So, think of your IP address as your device's digital passport, letting it travel effortlessly through the Internet streets. Happy navigating! How does routing work in the network layer? Ever wondered how the Internet knows where to send your data? Well, that's where routing in the network layer comes in. It's like planning a route trip across cities. Routers, which are like traffic managers, use special tables and algorithms to figure out the best path for your data to travel through the Internet. Think of it like using a map to find the fastest route. Routers look at things like traffic jams and how reliable different routes are. They then decide the best way for your data to go, making sure it takes the express lanes, avoids traffic, and gets to where it needs to go really quickly. In simple terms, routing is like the GPS of the Internet, making sure your data gets to the destination fast and reliably. So, the next time you're sending a message or searching for something online, thank routing in the network layer for being the behind-the-scenes guide that gets your data where it needs to go. What is the difference between IPv4 and IPv6? Stepping into the realm of Internet Protocol versions, let's simplify it. Think of IPv4 and IPv6 as different editions of the Internet Protocol, with the key difference being the length of their addresses. IPv4 sticks with 32-bit addresses, while IPv6 takes it up a notch with 128-bit addresses. Why is this important? Well, picture IP addresses as postal code for the Internet, and IPv4 is running low on unique codes. With our ever-growing army of Internet-connected devices, we need more codes. And that's where IPv6 comes to the rescue. IPv6, with its 128-bit addresses, gives us a massive pool of unique codes, making sure we have enough for all our devices and then some. It's like upgrading to a bigger address book for our expanding digital world. In a nutshell, my friends, the shift from IPv4 to IPv6 is essential to meet the demand for IP addresses in our ever-expanding digital landscape. So, the next time you're surfing the web, give a nod to IPv6 for ensuring there's ample room for all your devices in the vast address space of the Internet. How does subnetting enhance network efficiency? Let's dig into the world of making network work smarter. Subnetting is like the conductor leading an orchestra, breaking down a big IP network into smaller and more manageable parts. The result? A finely tuned network that's not just fast, but also neat and safe. Imagine it as organizing a huge library into smaller sections for easier finding. Subnetting does the same for networks, reducing crowding and making it easier to handle devices. And here's the cool part. It's not just about speed, it's like a superhero for security too. By making this smaller parts, my friends, administrators get better control over how things move around, stopping potential issues. It's a bit like having different rooms in a house, each with its own job. This separation not only makes managing the network easier, but also adds an extra layer for security. Subnetting lets administrators control things in detail, like who gets access and what they can do, but just in specific areas. This organized skill doesn't just make managing the network a piece of cake, but also helps build a strong and secure network setup. In simple terms, subnetting is a secret sauce for creating a smooth running network that's quick, safe, and offers a well-organized digital space for all your connected gadgets. What role does the Internet Control Message Protocol, or ICMP, play? My friends, ICMP, situated in network layer, act as a messenger delivering essential feedback to devices. It's the handy companion for error reporting, diagnostics, and exchanging control messages, making sure devices are in the know about any network glitches and keeping everything running smoothly. Imagine ICMP as a friendly helper who not only points out problems but also brings solutions. Besides reporting errors, ICMP comes with various message types for different tasks. Take ICMP echo request and echo reply messages. For example, they're like the backbone of the ping utility, assisting in testing network connectivity. But hold on, there's more. ICMP is multitasker. Its redirect messages act as traffic director for routers, optimizing routes and improve data flow efficiency. ICMP isn't just reacting to problems. It actively contributes to maintaining a responsive and well-organized network. In a nutshell, ICMP is the unsung hero behind network communication, making sure devices are informed, tackling issues, and actively shaping a dependable and efficient network environment. What is the concept of CIDR, or Classless Interdomain Routing? CIDR is not your usual address scheme. It's a real game changer that brings a whole new level of flexibility to how we divvy up IP addresses. Instead of sticking to the old school class-based method, CIDR steps in with variable length subnet masking, or VLSM, giving address space using a fresh perspective. Imagine CIDR as the superhero in the world of IP addressing, bringing in scalability and adaptability. Say goodbye to the strict rules of class-based addressing. CIDR hands network administrators the superpower of VLSM, letting them precisely assign IP addresses. This flexibility is like a breath of fresh air, allowing organizations to make the most of their address space, avoid wastage, and keep up with ever-changing needs of growing networks. But CIDR is more than just an addressing scheme. It's a toolkit for network wizards. It hands them the control they need for detailed subnet design, becoming the go-to tool for managing network efficiently and adapting to changes. In a nutshell, CIDR is a big step forward in how we allocate IP addresses, perfectly fitting the demands of modern and expensive networks. It's the key to unlocking a new era of flexible and optimized network addressing. How does Network Address Translation, or NAT, work at the network layer? In the world of networking, NAT isn't just about saving IP addresses. It's more like the bouncer at a club entrance, making sure only the invited device joining the global internet party. Its main job is letting multiple devices in a local network share a single public IP address, preventing the scarcity of IPv4 addresses. But here's the cool part. NAT also acts like a security guard by hiding internal IP addresses from the curious eyes of external networks. It's like giving your devices an invisibility cloak, protecting them from potential threats. But how does NAT do this trick? It's like a master disguise, playing with the addresses in the packet headers by adjusting source and destination IP addresses. NAT makes sure your private network devices can smoothly talk to the vast external internet. Think of NAT as a multitasking mediator, allowing your devices to use a single public IP address together to access the internet. It's the ultimate team player, making the most of addresses and boosting the overall security of your network. In a nutshell, NAT isn't just an IP address saver, it's a cybersecurity superhero, making sure your devices have a safe and efficient time on the internet. Here's to NAT, the guardian of network communication. Cheers. What is the purpose of Dynamic Host Configuration Protocol, or DHCP? Okay. Imagine DHCP as your network's behind-the-scenes hero, pulling off magical feats at the network layer. It's like having a wizard that automatically hands out personalized invitation or hears IP addresses and essential party details or configuration info to every device in the network. The main goal? To make setting up and managing networks feel like a breeze. Here's the magic trick. Instead of manually sending out invites, DHCP dynamically assigns IP addresses and related settings to devices. No more tedious manual configurations. Just a network that's not only simple, but also super efficient. But hold on, there's more enhancement to this wizardry. DHCP doesn't stop at addresses. It also serves up crucial details like subnet masks, default gateways, and DNS server info. It likes ensuring everyone at the party has the right map, directions, and a list of emergency contacts. In a nutshell, DHCP is not just about handing out addresses. It is the conductor orchestrating a harmonious network symphony. By seamlessly providing all the essential settings, DHCP ensures your network is not just hassle-free but also well-organized. How does the network layer contribute to end-to-end communication? Let's take a closer look at the network layer and how it plays a crucial role in making sure our digital messages travel smoothly from one place to another. Think of the network layer as a smart guide creating a roadmap for our data packets. Its job is to ensure these packets travel efficiently from where they start, the source, to where they need to go, or the destination, navigating through the big web of connected networks. To make this happen, the network layer uses logical addressing and careful routing. It's like having a conductor in charge. This conductor or network layer makes smart decisions about the best path for our data. It considers things like how busy the networks are, how reliable they are, and how fast they can carry out data. So, it is not just about getting data to its destination. The network layer is all about finding the best route. This helps avoid traffic jams and delays, making sure our digital conversation happens smoothly and reliably. In a way, the network layer is the hero working behind the scenes, making sure the symphony of data flows seamlessly across the digital world. Okay, thanks for joining us on this networking adventure today. If exploring the network layer inspired your curiosity, you won't want to miss the valuable insight waiting for you in our earlier videos. Click on these videos to expand your networking knowledge even further. Your learning journey doesn't end here. Subscribe, like, and share to stay in the loop with our tech exploration. Until next time, happy networking!